So okay guys, so in this section we will try to introduce you guys how to conduct for the non-seasonal ARIMA model. So in case like when the data does not show any kinds of seasonal pattern, that would be more suitable and more precise and compact for you to just use for the non-seasonal ARIMA model instead of the regular seasonal ARIMA. That saves the time and also more proficient for your coding development. So basically, as I already mentioned before, we have the ARIMA model including for the AR, the auto regression, with P which will be determined for the order of the auto regressive part. I, that means integrated, that's degree of the first difference C order, and the MA, that means moving average, that could be order of the moving average part. So in this section we will introduce you guys how to conduct for the auto ARIMA model. We one more time use this for just create it. Okay, so in this case I will go and teach you for the US chain data. And if you still remember that, that's growth rates of the personal consumption and income in the USA from 1960 into 2016, and that should be kind of like annual data. Alright, so if you gotta check it one more time, I want to see the structures of that one. So US chain, okay, and you see that's going to be 181 observation. That is quarterly data right there. That's a quarterly data. And we take a look into some first observation of the data first. Okay, and you see this including for the time series matching, the consumption data, income, production, saving, and unemployment. Right. But now to do that, we will plot the consumption time series, just the consumption time series. Now I'm not just going to do for the regular time series regression model, but just the ARIMA model, and that's the reason why I just need the dependent variable in the previous example. So I just need the data of the consumption only. So to do that, yeah, of course we will go into use for the auto plot, and I want to use the US chain data, but just the first observation. Okay, and up until here I can just put it like that, and if I plot it, yeah, of course there's will be just the US chain in the consumption only. But of course, like always, I love to just create for some kinds of decoration, plug in for the Y lab, and I want to do it like quarterly percentage change, right? Okay, this will be the plot. Okay, this is the plot. You see that could be this one. And to be honest, over here, if you can see it and observe it, you see like they know size of the seasonal pattern. Okay, seasonal pattern. There are no ways of the seasonal pattern, and that's the reason why I feel like, yeah, that should be great to just apply the non-seasonal ARIMA. We better. Okay, so that's the point. So we use this. So we're going to use the non-ARIMA model. Sorry, that's not non-ARIMA, not non-seasonal ARIMA model. So by just specific, clearly seasonal will equal to false. Okay, and remember in this one we use just to be just auto ARIMA. Okay, the function. So they will be just select the model automatically for me. Of course, it's not all. So it's just like in a live manner. what does it mean in the line manner? That means it's not go in deep to just kind of clarify for all the model possible, but just run in like interface of them, and it kind of superficial. So in case like you want to get all of the possible ARIMA model can be, after you will have to clarify for another function, but I will show you later. But at first you will see like they can automatically determine for the integration order into the moving average order and the auto regression order. Okay, so I'm going to use for the auto.arima function, and I want to use the you will change the time series of the consumption, and I want to see seasonal will be equal to fall, and that should be my model. But I want to say them into the fit object and summarize for in detail. Okay, so when I summarize it, it can show out for more in detail about all the kinds of stuff. Over here, that should be ARIMA 103. That means they have a one auto regression order with 3 moving average order, and 0 for integration, and that should be how the people do it. You can also see it like the AIC, the AICC corrected, and the BIC, and also for the forecasting error. This will be all the thing available over here, and the mean over here. I already introduced you guys how to just understand about that. The mean value when you after create and write out for all the function, you can measure for the C, because the C are not available here. And in long term, one of the assumption of the model will be like in long term, all the values will go into the mean values. So that means in long term, the Y will be going to equal to the mean values, and also the Y t minus 1. That means the previous before they will be also just go associate with the same order. Okay, so that's why like we can put it the yt's, that will be the number of the mean, and also for the yt minus 1 will be the same with the number of the mean, and you can easily just use for the algebra to just calculate for the constant. Okay, and that will be how the people create for the non-seasonal ARIMA model. And another thing that you can easily see it like with this one, right? The model over here, that will be ARIMA 1, 0, and 3. Okay, and that will be the ARIMA model that we are using. Moreover, we can use the fit model to forecast the next 10 periods. Okay, including the 80% and 95% PI, that's mean prediction interval, and you can use this like fit, and you apply it for forecast x equal to 10. That means 10 next observation. Okay, and you can see it's over here. This will be the point estimation. However, at the same time, you can plot it. So I will just copy, and then I want to just plot it. So I will say auto plot, and let's create it over here. And if you really want to include, then includes equal to 80. That can have to create for the 80% of the prediction interval also. But however, I want to show you something over here. Okay, so in this case, you see like even when it has a seasonal impact, and we had to change a little bit in the beginning of the forecasting, right? We jump up like a drip, and then we slow it down. But because we just have a 10 next observation, the thing just go like that way. Just in this case, okay, just in this case, if D and C that will be the constant of the model we already show you, right? The C's over here, that's different to 0. I already created, and so like C would be like 0.3 something. So the C and the D, C different to 0, and their d that means the integration order, that will be equal to 0, sorry, that will be this case. Okay, so the long-term forecasting, okay, will go to the mean of the data. So the mean of the data already posted here. This will be 0.74454. Okay, that will be the point. So you wanna go in to do. I would just copy for the same function, but I'm going with the longer periods left to 30 observation. So I want to forecast for the next 30 periods. Okay, and then at the same way I order it and plot it, so you can see how it look like. You can see this in long term is going to start to be average, right? It start to be quite as close to the 0.7454 something, and even when that way I go in like 50 more observation, it's the same, just go into the average. So that's the reason why I want to say like you have to be very careful about this part and just pay more attention into. Okay, now let's go and talk about we can check their autocorrelation function and their partial ACF plot. Right? You can see it and see like how would be any kind of problem of the autocorrelation, and in those cases we can just clarify about how we can measure it. So we use GGACF function, okay, for the time series that we are using, the consumption. Okay, so plotted over here, you can see that's the kind of autocorrelation between the first large, the second large, and the last large into the first one, into the current values. But however, it's very weird with me, like it's very weird. When the first one, that's be fine, okay, like the our current value, they're related to the last one value, that means appears before. But however, the second order still makes sense, but the third order, they're even stronger than the second order. And normally we think like, yeah, maybe has some kinds of problem when the first and the second large, they can have the impact, and also the second part, they have the relationship to the autocorrelation to the third part. And that's the reason why the first and the third part, they have the correlation in that way. And that's the reason why the people later, they create for the GGAC PACF, okay, that's the new function for the partial autocorrelation function, and we apply it for the same time series to get a better pattern. And you see like this over here, this had removed for the impact of the previous one, and now it makes more sense when the first the last one have an impact into their current data, and the second and third one, they reduce and diminishing for the impact, and that makes sense with me. So that's the reason why people sometimes they want to use for the partial autocorrelation function for that way. Okay, however, is it a more convenient way to produce the time series, the time plot, the ACF plot, and the PACF plot in one command. Okay, so I will use GGTS, that means GG of the time series display, and I use this for my time series US chain, the first one. Okay, and at the same time they create for the original time series the original ACF and the partial ACF. Okay, that's more convenient. You don't have to just write out them separately. However, we can specify the ARIMA model if you really want to do it. Okay, So for example, over here I want to clarify for a new function. I use the ARIMA function, and I want to use for the chain the first time series, and I want to use the order of the function equal to like 3 0 0. That means I make it like for the three order, the three order in the autocorrelation. That means we have the relationship to the historical last 3, last 2, and last 1, and we don't have the integration, and we don't have the moving average. And I can run for the model. Of course, I can say them by the fig 3, fig 2. Okay, that should be my ARIMA model, and you can summarize them to see the main thing. Okay, the main thing about the fig 2. Fig 2. Alright, and the same way I can specify about the fit 4 function with the ARIMA model, but in this case I will be 0 0 0 3. Okay, and fit 4, that should be the point. And you can change and you can compare between the ACI, the AIC, AICC, and BIC, and you can see it over here, right? Compared to the previous one, the model number 4, they have a lower BCI, ACI that should be quite a little bit larger, and this one, okay, larger. The second order, the second model, they have a better appearance compared to the previous one. And the model 2 for the third model, this will be the second model, right? They are a little bit different to the first model, but they provide quite the same result. If you see, oh no, I'm sorry. Yeah, we have to compare it with the fifth one, the fifth model. Summarize. Okay, the fifth model, and you can compare this. This is a fifth model, the fit 2 model, and fit 3 4 model. Okay, and I will just write it out for you to see it. So the fit model, this will be auto created. The second model, they would have been created manually. Okay, ARIMA 300, and the last one, the fit model 4, that's been created manually too. And we can see that's the second model. They are doing it quite well. Okay, they are doing it quite well compared to the previous one. This is because, as I already tell you, because this one we clarify about this one, and even when we use for the auto ARIMA model, it doesn't mean that this can create the best option. Okay, it cannot create for the best option of the model. We can compare them all. So finally, we can run all the thing into, if you really lazy and you want to put all the thing into the power of the computation of the computer. So we can use for the in-depth ARIMA auto with the step y equal to 4, approximation equal to 4, and we verify the seasonal equal to 4 to just create for the function. It takes for a while, but when you summarize it, it can create it, and you see like it's really select for the new model. It's 3001 00. Okay, and I have a summary for all the 4 model in just one page, and you can see like the fit number, the fit model, the fit number 2 and number 3, the 3000. Okay, they're the same for the fit 2 and the fit 3. They will be create manually and automatically, but they both better than the original auto ARIMA model and another one, ARIMA 003. So that should be the way for us to select for the model. Remember, just based on the AIC, AICC, and the BIC, that should be the best option for us until now.